Now we're ready to actually write our Hello World program. The first thing that we need to do is we need to learn how to write to standard out. If you know any other program language, this comes in all different formats. There's print line, there's cout, there is console.log. There are all different kinds of ways that we call this functionality in different languages. But even before we actually write something, we have to actually load the data itself. As I said, there's not very many variables. There's not really any variables in the way that we have variables in any other program language. We can't store a string by assigning it to a variable. What we have to do is we actually have to put that data into memory when our program executes. And then we tell the operating system where that memory is, and it'll print out what's at that memory. We do this by using the data section of the program. And we do this by just putting .data, and this is a directive that starts the data section. As I said, we have to put this into memory. And so how do we know where in memory it's going to live? It could be at address 1, address 5, address 10. We don't know. But what we can do is we can put a label here, and this label will allow the assembler to calculate all this for us. So let's just call the label here hello. We have to say what kind of data it is. And for this, it's going to be ASCII. You'll see that it's important later because we'll use different sizes of data, whether it's 1 byte or 2 byte or 3 bytes. But when we use ASCII, what it does is it takes all the characters within the double quotes and turns into the numerical value, the numerical ASCII value for us. So if we put hello world here, it'll do that. Interesting enough, if we wanted to actually write this out, what we could do is we could even put like the hex values or the decimal values or the octal values or the binary values of all the letters. It would work just the same because it's always going to store the same information in memory. It's always going to store the numbers into memory. So looking at the list, we can see that the write operation is 4, supervisor call 4. And so in the same way that we do with the exit, we're going to move an immediate into register 7. And that immediate is going to be 4. The next thing is that this call, it takes 3 different parameters. The first parameter is the file descriptor. And for this, it's always going to be 1. Standard out is a special file, and it's always 1. So we can do move, and we can do the first parameter, register 0, number 1. And then the second parameter is the address of what we want the operating system to output to the standard out for us. Again, we don't know. I mean, we could calculate where it's going to be in memory in relation to the instruction, but it's so much easier just to have the assembler to do it for us. And we do this not by move, but we do it by load register, which is LDR. And we'll do this into R1, which will be the second parameter. And this is kind of a pseudo instruction, again, because it's not an actual address. We're going to have the assembler calculate it for us. We'll put an equal sign and then the label name. And then the last parameter is the length of our string. So how many bytes of memory is it going to actually read? And we'll put that in register 2. If we count HELLO space WORLD exclamation point and then line ending, it's 13. And then again, SVC 0 to actually make the software interrupt, to make the supervisor call. There is another way of writing this supervisor calls. I prefer this way only because it's a little bit easier for me to not make mistakes. The other way is by putting the supervisor call here with the offset. If you want to do it that way, that's fine. You don't have to put anything in register 7, but I strongly suggest, especially when you're trying to see how this all works, that you use the same format that I'll use throughout these videos. And then we exit, and this is exactly the same as it was from the last program. And so let's try compiling it and running it and see what we get. The first thing we need to do is assemble it. Our output file is going to be main.o, and our input file is main.s. And then we need to use the linker, which is ld. Output file is main, and the input file is main.o. And if we run this, we hopefully will see hello world here. Oh, and we do. And so if you got hello world up on your screen, you're doing great. Everything seems to be set up quite well, and you should be fine starting the rest of the videos.